Hello, Pre-AP Chem, Mrs. Berger here, and today I'm going to teach you how to balance chemical equations. And balancing, the reason why we do it is because we cannot create or destroy matter in a chemical reaction. But if we're looking at a chemical reaction here, let's take a look at this. We've got sodium chloride and fluorine gas. Remember that fluorine is one of those diatomic molecules, one of those Brinkelhoffs, where it's always, when it's by itself, 2. And we get sodium fluoride, because sodium's a +1, fluorine's a -1, and chlorine gas. Okay, well, if we're looking at the left side here, let's do a little, if we're on the left side, we have 1 sodium, we've got 1 chlorine, we've got 2 fluorines, 2 F's, haha, hopefully not like your report card. Jokes are just not the same, like not in person. I hate this. I miss you guys so much. Okay. And on the right side, we have 1 sodium, 1 F, and 2 chlorines. So as you can see, we've got an imbalance of chlorines and fluorines here, which is not good. If we were to leave this equation as is, it would be unbalanced, and it makes it seem like we're losing fluorine atoms and we're gaining chlorine atoms. And in reality, a chemical reaction, if you remember from last week, in a chemical reaction, molecules and atoms will change places, but they won't necessarily, they definitely won't be created or destroyed. They won't leave the system at all. Okay, so what I'm going to teach you today is how to balance them. Now, the way that I balance them to start you guys off is by using a chart that looks like this, reactants and products chart. When we get started, I want you to show your work using a chart like this. You know, maybe for like the first few problems on the homework, I'm going to require, I would say, you know, I'm going to require it for, you know, at least half of the problems on the homework. I don't know, we'll see. But I'll decide before the end of this video. I'm going to want you to show me your work, because it's kind of hard to do otherwise when you're first starting out. So as you can see, if I've not made it blatantly clear with everything written here, that we are not allowed, no time, never, to change subscripts. Okay, you cannot change your subscripts. You cannot change what something is. So you can't be like, oh, look what I'm going to do. I'm just going to put 2 here and 2 here. No, that's dumb. Don't do it. Okay? So here's what you got to do. You're going to set yourself up with a little chart. And I'm going to move on to, here we go, right here. I'm going to make a little chart over here. Okay. I've got sodium. I've got fluorine, and I've got chlorine. Okay. On my reactant side, my left side, I've got 1 sodium, 2 fluorines, and one chlorine. On my product side, I've got 1 sodium, 1 fluorine, 2 chlorines. Okay, and I'm just going to erase what I wrote right here because it's getting in my way a little bit. All right, so remember I said we cannot change subscripts. The only thing we can change is the amount of molecules of them. Because if we're looking at this from the point of view of the molecules, we've got 1 sodium, which is going to be black, bonded to 1 chlorine. Okay, and then we've got F2. F2 is 2 green balls stuck together. Okay, and then what we end up with in the end, so we'll turn this black, we have this with this, and now 2 of these stuck together. Okay, but you know, the way that this would actually play out is that we would say, hey, you know what, I need more fluorines on my product side. Well, if I put a 2 in front of this whole thing here, 2 sodium fluorides, that gives me 2 fluorines, and that also gives me 2 sodiums. So I have this now, 2 sodium fluorides. Okay, well, that now changed my sodiums on my left-hand side. Now my sodiums, I only have 1, and chlorines, I have 1 as well. So the way I can manage this is by doubling the amount of sodium chlorides. So now I have 2 and 2. So now I have an even amount, or the same amount of each thing on both sides of my equation. So I'll put a 2 here. So it takes 2 moles of sodium chloride, 2 molecules of sodium chloride, and 1 molecule of fluorine. So if there's no coefficient, you assume that it's 1, to produce 2 moles of sodium fluoride and 1 mole of chlorine gas. Okay, let's do some more practice using these tables. Go to the next page, please. Hello, where are you? And what I'm going to do is I'm just going to start working on your homework, because there's a lot of problems here. So I'm going to pick a few and give you a few strategies. Okay, so let's take a look at, for example, which one do I want to do? Maybe I will do, we already did this one on the first page. Let's do number 6. Okay, number 6, it's got some polyatomics in it. It's got sulfate in it. And since my sulfate, it's not broken down into anything else. My sulfate really stays a sulfate. Like, it doesn't break down into sulfurs and oxygen. So I can leave it as one big thing. So I'm going to do the work for it right here. Whoa, big chart. Okay. Change that. Reactants and products. On my reactant side, so we got to write down all the things that we have. We have aluminum. We've got bromine. We've got potassium. And we've got sulfate. So I've got 1 aluminum, 3 bromines, 2 potassiums, 1 sulfate. Here, I'll erase my markings there, my highlights. Okay, and on my product side, for aluminum, there's 2. Bromine, there's 1. Potassium, there's 1. Sulfate, there are 3. Okay. Sorry. All right, well, the first thing that kind of jumps out to me, really, there's no wrong way to balance to start off. You just kind of get started. But I don't like the fact that I've got 3 sulfates here and 1 here. So I'm going to go ahead and I'm going to put a 3 here. Let's see what that does for me. Okay, so that evens out my sulfates. But then that also gives me 3 times 2, 3 K2. So that gives me 6 potassiums. That's a lot of potassiums. So let's see how I'm going to respond to that. All right, so I know that now I have 6 potassiums on my reactant side, so I'm going to need to balance that out on my product side by putting a 6 here. That now gives me 6 potassiums and 6 bromines. Okay, so what's a teacher to do now? Give it a second. Well, if I put a 2 here, right? If I put a 2 there, that gets me the 2 aluminums that I need, and also is 2 times 3, so 6 bromines. Okay, so my formula is now balanced. It's 2, my coefficients are 2, 3, 6, 1. Okay, so this is the homework sheet, by the way. So let me just erase this. Okay, I'm going to do one with you with a polyatomic that does not remain the same. So you can't always just keep the polyatomics the same. The polyatomic, for example, here we've got hydroxide. And I also want to point out to you here that you have hydrogens here and here, okay, which is annoying, but it's okay. We're going to deal with it. So we have sodiums, we've got hydrogens, and we've got oxygens. And I think that's all we got. So we have a sodium, we've got 2 hydrogens, and 1 oxygen on my left-hand side. On my right-hand side, I have 1 sodium, I've got 1 oxygen, and 1 plus 2, which is 3 hydrogens. Okay. Folks, I gotta tell you something. I don't like it when I have odd and even numbers on either side, because something easy isn't going to come out of that. So what I'm going to do immediately right now is I'm going to put a 2 in front of my sodium hydroxide. Okay, so what that's going to do for me is it's going to give me an even number now of hydrogens on my right hand side. I have two hydrogens from here and 2 here. So now I have 4. So that's something I can work with, okay? But that also now gives me 2 sodiums, okay? Because that 2 is in front of that whole sodium hydroxide. Okay, Mrs. Berger, what's a girl to do now? Well, let's think about it. I need to get more hydrogens on my left-hand side. So if oh, you know what? I didn't even write this down, but that also gave me 2 oxygens over here. All right. So I've got, if I just do this, 2 H2s, that gets me 4 H's and 2 oxygens. The only thing I need to do is take this sodium and put a 2 there as well. So I get tuna. Ha ha ha. Okay. So what I'm left with is 2 sodiums, 2 sodiums, 2 waters, 2 sodium hydroxides, and 1 H2. Now, I want to point something out to you right now. So if you haven't been paying attention, pay attention now. Sometimes you might overshoot your balancing, right? You might overbalance something, and you might end up with something like this, right? You might end up with 4, Berger, come on, 4, 4, 4, 2, okay? Well, in this case, these are all divisible by 2. So if you end up with something with coefficients that are, first of all, if everything has a coefficient, that's not always a problem. But if everything has a coefficient, you have to make sure that all those coefficients are not divisible by the same number. If they are, you just need to, it's not hard, you just need to divide them by their common denominator. So this would be 2, 2, 2, and 1. Okay, so if you overbalance, which you will at some point in your life, then that, just know that you can do that. All right, so I'm going to show you, let's see, another good one. I don't know. Let's do number 14. And just to let you guys know, the easiest way to attack these is to leave the oxygens and hydrogens to last, because those tend to exist in more than one location, meaning like being in multiple different molecules. So you really don't want to be balancing them and have to move them around more than once. So we have hydrogen, we've got chlorine, we've got calcium. So normally I would see this and say, oh, carbonate, cool, I can leave that as carbonate. But actually you can't, okay, because it doesn't stay carbonate on both sides. So we've got calcium, we've got carbon, we've got oxygen. Okay, so this one's 1, 1, 1, 1, 3. Okay, we got, let's see, we've got 2 H's here, that's it, 2. I'm like looking at the wrong one. Hold on, the 2 H's are here. Okay, we've got 2 chlorines here, calcium chloride. Let's see, we've got 1 calcium. we've got 1 carbon, and we've got, let's see, 1, 2, 3 oxygens. Okay, so the only things that I'm really concerned about here is the fact that I don't have as much hydrogens and chlorines. But lucky for you, and this is actually a pretty simple one, I'm just going to toss a 2 here. That gets me completely balanced. How nice is that? Okay, I'm going to do another example for you, and it's on the back, or on, I guess it would be the back if this was photocopied, but it's not. Oh my goodness, you're thinking to yourself, Miss Berger, are you really giving us word equations? Yes, I am. Okay. So that means you really need to be on your game with the naming, because if you're not translating these correctly, there's no way you're going to balance it correctly. Okay. So I'm going to start with number 2. We've got aluminum bromide. So aluminum I know is a +3. With bromine is a -1. So it's going to be AlBr3. And chlorine gas. Remember, chlorine is one of those Brinkelhoffs. Cl2. React to form, that's an arrow. You learned that last week. Aluminum chloride, again, aluminum is a +3, AlCl3, and bromine gas, Br2. Okay, so I'm going to draw myself a little table here. Do I need more? So I'll just do it right here. Aluminum, bromine, chlorine. Okay, aluminum, there's 1. Bromine, there's 3. Chlorine, there's 2. So chlorine on this side, 3. Bromine, 2. Aluminum, 1. All right, so 2s and 3s. So when we were dealing with 2s and 3s, when we were naming chemical compounds or coming up with chemical formulas, we would have to meet at 6. And that's what we have to do here. Okay, so for bromine, here we have 3. So to get to 6, I have to put a 2 here. Okay, so that gets me 6, and that gets me 2 here. Okay, and now over on this side, I can put a 3 here, and that gets me 6. Okay, now I need to get my chlorines to balance. So again, I need to get to 6. So I'll put a 2 here, because that gets to my aluminum and my chlorine. So it gets me a 6, and that also gets me a 2, which is balanced. And so I can put a 3 here, and bada bing, bada boom, you are balanced, my friend. Okay. So that's all that I'm going to show you in this video. The rest of this is going to be your assignment for today. And I decided in my infinite wisdom that I do want you to actually show your tables for all of these today. Just because, and I'm not saying you would look these up, but I mean, there are apps on your phone that will balance equations for you. So I want you to be showing your work and thinking about how they balance out. Okay, so make sure you show your work on all of these. Berger out. Have a great day.